This podcast is brought to you by the Extension and Communication for the Australian Cherry Industry Project, funded by Hort Innovation using the Cherry Research and Development Levy and funds from the Australian Government. For more information, please visit horticulture.com.au. Welcome to the Cherry Picked podcast, the podcast that brings you the sweetest insights, tips and stories from the world of cherry growing, packing and consuming. I'm your host Jess, and I'm here to connect with growers, researchers and enthusiasts to share the wisdom, experience and innovations that make cherry growing a rewarding experience. Whether you're tending to a backyard tree or managing hectares of orchard, this podcast is your go-to resource for everything cherry related. So let's get into it. Hello everyone and welcome back to another episode of the Cherry Picked podcast. How are you guys all going today? We're going to talk about all things microbe and soil in this episode, and winter is a great time to start thinking about the role that microbes play in the orchards and doing some digging around on how you can improve them and get the best out of your orchard. To help us uncover the secret of microbes this afternoon, I'm joined by Edwina Murray. Edwina, welcome to Cherry Picked. Can you please introduce yourself, your role, and who you work for?
Sure. Well, thank you firstly for having me. Yes, I'm Edwina. I work at New Age Microbials, but I'm based in Young, cherry capital, so place to be. I have ground in entomology, but also looking at systems and where, they're changing and how biology plays a role in that. So, yeah, very excited to be here today.
Great. And we met down in Young, Edwina, and what I was really drawn to with you was your passion for all things entomology and microbiology and how we can improve our orchards. So today, I guess, I want to give the listeners a bit of an overview of what nutrient cycling is, how it works, some of the roles that microbes can play in that, and then getting a bit more in depth of the different roles that they play within the soil and plants, and then how potential biological solutions could improve that. This afternoon, can you tell us how nutrient cycling works and the role that microbes play in it?
Yes. First of all, what I'd like to say is that I know that there's, microbes and adding microbes into systems. It's sometimes a very confusing space, but essentially when you look back at the science of nutrient cycling, especially things like the nitrogen and the phosphorus cycle, they're primarily driven by microbes. So we need to remember that even though this space is difficult and big and hard, back at the base roots of science, it's where we rely on forming our soils and the nutrients that we're obtaining from even our fertilizers and things like that. I'd like to ideally start with nitrogen because nitrogen's a big ticket item, generally speaking.
Yes, very much so.
Everyone loves a bit of nitrogen, and so do the plants. So, nitrogen fixing bacteria is something that we all know pretty well, and probably the most widely known one is rhizobia, which is applied to pulse crops and pasture crops. And what they essentially do is they take the nitrogen out of the air, which is two nitrogen atoms, and it can, using certain metabolic processes, transform that from that gaseous form into ammonia and nitrates within the soil systems. And essentially what it is that they eat it, and then in their bodies they metabolize it. And then when they die, and the plants that, they associate with die, they break down and form that nutrient into the soil. Now, equally speaking, there are denitrifying microbes in the soil that take those food sources of the ammonia and the nitrate and then essentially put it back out into the atmosphere. And what that does is it forms this cool cycle where there's constantly nitrogen moving between the atmosphere and the soil systems within the environment. And essentially that's where farming systems developed. That's what they relied on for their nitrogen for many, many years, until the Haber-Bosch process was created, which is,
Yeah.
pulls it. And so it's a system there that we kind of forget about, but it's actually functioning whether we like it or not. The little things that we do here, there, and on the farm will affect how well it plays. And the big things that we need to think about is taking care of those bacteria that are doing essentially that free role for you on your farm, and thinking, what do they need to survive, and what practices is damaging them.
And so with the nitrogen cycle, so there's the natural process, like you've just explained, that is forever occurring. Mm-hmm. And so we can speed it up now. And what would be the benefits of speeding up? More nitrogen has been produced, or better for the plants?
Everything, I suppose, especially when you're talking microbes, is a numbers game. More microbes, essentially, I like to look at it as microbes in your soil are like having livestock on your farm. The more you have, the more likely you're going to get a return on your investment. So the more you have, the more nitrogen is going to be pulled out of the air, the more nitrogen that's going to be fixed in your soil and available, and then also being processed into, safe sources, which will break down slower over time. Yeah, to resource it, you want to boost. You want to have more of that livestock. And I completely understand that, there's a time and a place for fungicides, there's time and a place for insecticides. Everything needs to be utilized in a farmer's toolbox. But you just have to think, okay, maybe I've done something to address one issue, but what's that doing for, the microbes? Do I need to maybe think about putting out a little bit more organic matter to stimulate their growth, or inoculate, or, there are lots of options there.
And so you've got the nitrogen cycle. You also mentioned that microbes play an important part in the phosphorus cycle. Can you explain that a little bit more deeply as well?
Yeah, for sure. So phosphorus cycle it's a bit different. Once again, phosphorus is it's a finite resource in the soil. It essentially forms over many, 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 many years of breaking down of, rocks and things like that. And there's two main pools. There's an organic pool, which sort of comes from the natural resources. And then there's an inorganic pool, which is more of the harder stones and rocks and things like that. Microbes in the soil, equally just like plants, like to use phosphorus as a food source. So what they do is they can produce enzymes and also organic acids, which help these different pools break down faster so they can consume it. And then once again, like the nitrogen cycle, they'll die and have this phosphorus source in them, which then becomes plant available.
It's pretty cool, isn't it, how they've got all these different cycles happening within the soil. And I think one of the things that I find really cool about soil is that in 1 gram of soil, isn't it something like there's more microbes and things happening in 1 gram of soil than there are people on Earth, something like that. But so you've got these nutrient cycles going along. How do the different microbes within those cycles play a role within the soil-plant interaction? Is there a difference between fungi versus bacteria? What are the ones that we should be focusing on to improve these cycles as much as we can?
Good question. So essentially speaking, when you're talking about, the microbial sphere or the microbiome, you're talking about bacteria, funguses, viruses, and protozoas. There are, of course, examples of using viruses in agriculture which have been quite effective, but obviously they're viewed as well as mostly diseases. So we're less likely to, try and boost a virus functioning in an environment. But bacteria we're talking about apples and oranges here when you talk about bacteria versus funguses. Funguses, I kind of like to think of them closer to a plant. They have root systems, they're not root systems as such, but they can grow essentially things that look very much like roots to access certain parts of the soil. We've all seen, a fungus growing, say, on an orange in a fruit bowl, and you can see those little filaments coming out. And it's the fungus which is breaking down and utilizing, that piece of fruit for an energy source and transforming, say, the nitrogen or the phosphorus in that into something that they can use and pass on through the systems. Bacteria is a lot smaller. It's a lot more, or can be a lot more robust in systems, just depending on what form it is. It can be in a spore form, or it can be in a vegetative form. Spores are extremely robust, is that they can survive in very tough conditions. So bacteria can be a little bit more likely to persist in environments. Funguses as well work together. And there's some good evidence out there that, they can form relationships in the soil as well. So we often talk about, 1 + 1 = 3. A really good example of that is something like a mycorrhizae fungi, which is essentially a fungus that grows throughout the grows throughout the soil system, and has such fine filaments as it grows that it can get into the aggregates where plants can't reach. And then, say, putting something with it like a bacillus, which has the capacity to, take what the mycorrhizae can access and then use those organic acids to metabolize them to make them plant available. It's a really nice system where those two things are working together, and then they can form also associations with plants as well.
And so in an orchard system, out of fungi, bacteria, spores, what do you perceive to be the most beneficial, or is it a combination of all of them, diverse amount? What would be the best for those nutrient cycles we were talking about before?
Look, the really excellent thing about an orchard system is that it's not an annual crop as such, as that the root system is there for quite a long period of time. Where you want to be looking at is things that will associate with your roots. So essentially start delivering better nutrition to the tree. And I like to think about poor trees that if you could pick to be planted anywhere, where would you choose? They don't really get much of a choice. So they need to rely on the bacteria that can move and the fungus that can move in the soil to start delivering those things. One of the ones that I really like is using a fungus that can, be very microscopic and get into those areas of the soil that the plant just can't get to, and deliver it to a bacteria which can form associations with the roots and then metabolize those, say, raw forms of phosphorus or nitrogen and deliver it to the plant. We have seen some good evidence of that in some trials that we've done around young. They're still very much in the preliminary stages, and we look forward to what happens in spring, because that'll be the telling time. Yeah, it's certainly the theory is there, the science is there. It's just about getting the application in the systems correct.
And that's probably a good segue there, Edwina. I mean, I'm really interested to hear about what you guys do and how you capitalize on that natural environment and improving our soil and microbes. So for you, how are we looking at our inputs differently that we're putting into our system? What's some of the things we should be thinking about, and how it has an impact on the crop and environment, and where does NEM step in to assist growers with that?
Essentially, and something that I want to make relatively clear is that microbes or natural additives aren't replacements for fertilizers and things like that. However, what they can do is enhance how those fertilizer inputs are utilized, but also create those systems in the environment where if you're providing them with some sort of natural food, they can break it down into a more slow release fertilizer source into the system. So we would love to be everywhere all the time helping everyone, but obviously can't be.
The little headless chooks running around.
Yeah, pretty much. Yeah, we like to ideally work with farmers and go, okay, so you're putting in this much amount of fertilizer, Is that sort of, say, ureas and things like that, which are very quick boom and bust? Or is it, you're putting in things like chicken manure, which is slower over time? And what are you doing in those systems to hold on to those nutrient sources so they don't leach out of the system? And microbes and, say, plant extracts can be an excellent way to do that, because the microbes themselves add an extra step into that natural process.
Okay. And so with adding to that natural process, what are some of the trials and products that you guys have been using to do that?
So we've been born and bred new age microbials in rhizobia. So that's broadacre work. But we've
more focused on nitrogen?
Yes, nitrogen fixing.
Yep. Cycling.
Yeah. And recently year or 2 years ago, joined with an international company called Lalamond, who are excellent at essentially making microbes. And we've got access to some of their products, which are things like these bacteria and fungi and plant extracts that will help additionally from, the nitrogen source that we came from. So I spend a lot of my time reading, understanding systems, to figure out where exactly these things can fit and where they can help. So we're, of course, looking at the whole broad range of what we could potentially do and bring in. But we've started with a product that's a bacillus, and it's called Laurise Dart SC, and a mycorrhizae, which is called Laurise Max. There you go. And then we also have another product that's called Laustiv Osmo. And the three of them, we picked them because they're sort of a snippet of each of the different inputs that you could put in. One's a fungus, one's a bacteria, and one's a plant extract, essentially. And the three of them together, you can utilize to manage things like stress, water uptake, or enhancing those nitrogen cycles. So that's where we're at, Cherry Systems particularly, because of the quality aspect.
Yeah.
Definitely, it's a very difficult space, and I really take my hat off to cherry growers, because it's something that can be ruined with a storm. It's something that don't quite get your fertilizer right and you've got too many leaves, not enough fruit. So it's a space where we really think that putting in something that sort of buffers that system but also ensures it in some way a little bit, just to make it a little bit less vulnerable, is an excellent opportunity.
That's what we really like to hear, because I'm glad. Thank you for acknowledging the challenges. I know a lot of listeners, like you said, quality is key for the Australian cherry industry, but we are up against it a lot in terms of pest disease, storm surges, wind, anything can come along. So a lot of the growers that I talk about will say, I like to have a diverse range of things in my toolkit, particularly when it comes to nutrition, to make sure we're doing the right thing. I want to dive a little bit deeper into the different types. Now, we've spoken very high level about the different microbes and how they might be beneficial, but if a grower is trying to apply a biological product or is delving into that sphere, what will they encounter in that space?
We get asked that question a lot, because it seems as though if you start looking into it, there's biological products hiding under every rock and sphere around the place. So yeah, they're just everywhere. And essentially what's the confusing part is that the term biologicals is given to so many different product types. And essentially it comes down to 4 different groups. There are biological chemicals, so like pheromones, hormones, growth regulators, enzymes, vitamins, things like that. And then there are also plant extracts, so oils or things that are like stress mitigators that are extracted from plants using amino acids or their byproducts of amino acids. And then 3 microbial agents. So that's when we start talking about things that are actually alive and living. So bacteria, funguses, viruses, things like that. And then sort of one other group on the side of that is that it's food source to provide to stimulate, the microbes in those environment, or something that stimulates the efficacy of those other three that I mentioned. And then within that, there's even more, which is, again, confusing. Biologicals then can function as biocontrol agents. So if it's something that's registered, it has the potential to control or suppress a pathogen or a weed or a pest. And these products do have to be registered in Australia. So that's something I think we need to keep an eye on, is that anything that claims control or suppression has that registration to prove. And then biofertilizers, which essentially assist in nutrient availability and efficiency. So like the bacteria I was talking about earlier. And then biostimulants, which essentially, stimulate a natural process in the plant, which whether that be stress tolerance or water uptake, things like that. And then that last one, which I mentioned, which is soil biology stimulants, which is essentially a food source to provide to all the other functions.
My question, and forgive me if you can't answer it, if you were a grower, what area would you be starting in to get that maximum kick first, or to delve in? What area would you go for?
So I don't think going into any particular area is right or wrong. I think what is the right approach is looking for products that provide high quality. Mm-hmm. A lot of the failures unfortunately happen because something didn't work because it stored incorrectly, or it wasn't alive when it was delivered to the plant, unfortunately. So good indicators of what a quality product look like is listing of the active ingredients in it and their concentrations. It's really important that I think we treat biologicals like we would any other farm input, that we can look at a label and go, okay, it's got this in it at that concentration, and this means that for me. You wouldn't just pick up a drum of Roundup and hope that
spray it all over the place.
Yeah, hope that it's the concentration that it is, and that it's actually got glyphosate in it.
Yeah.
And then the next step on top of that is it formulated, or is it just something that someone's ground up in their back garden and put in a container? Does it have a good shelf life? Does it have any shelf life? Is it mentioned in there? Is it the spores, which are more environmentally resistant and persistent, or is it those vegetative cells which are more actively metabolizing, so will eventually run out of food when they're in a finite container? Is it pure? Is it, that when you pick up something it's 90% this and the rest is the formulation, or is it you don't know? And this is not to say that products that don't have this information available aren't necessarily good. It's picking up a product that you can know and trust and be able to get this information relatively simply. The next step as well is, I think, data and information. Has it been tried? How was it applied? In what conditions does it need to be applied in to be successful? Well, microbes and any sort of biological product, there are limitations to them. Of course, they're, a natural thing. If you put lip balm on your eyes, you're not going to get plump lips. Like it's about getting, the right thing in the right place at the right time to do the right job.
Yep.
Yeah.
Yeah.
So, what I would do is really question the companies, ask them, what have they done to prove it? How is it best for me to implement it on my farm? What's the active ingredient? Is it a good concentration? And that'll help you figure out exactly what you need to do and also prevent failures.
Where do you suggest, like you said, you meant have a look at the different company information. Are there any good resources or anything online that growers could have a look at in terms of understanding these systems a little bit more?
Yeah, definitely. There is, just generally speaking, a lot of information on the web. Some of it is very highbrow, which unfortunately is sometimes a bit difficult to comprehend.
Yeah.
What I would do is, start simple. start talking to people, especially because people can explain a lot better to you what you need to know than going to find it out. And I mean, these companies, essentially, they should have someone available for you to talk to as a good place to start. And then, to go into field days and things, requesting information there if that's something you want to know about. But it's not easy, and I do acknowledge that.
Well, I think you as well as probably is a great resource. I mean, just having this conversation today, I've learnt a few different things as well. So hopefully talking to people like yourself or anyone from NEM might also be able to have that conversation with growers about what could be implemented on farm.
We're always happy to have a chat to anyone because, at the end of the day, this is pretty much all we do. We live and breathe.
Your bread and butter.
Yeah, we live and breathe biological. So we're always, and look, the reality of the company, like we're a bunch of nerds and we love it. So we're happy to talk science or farming or whatever it is all day.
And all of you, everyone that I've met from the team has been really approachable and very friendly and very knowledgeable. So I do encourage everyone to get out there and have a chat with you. Edwina, before we wrap up this afternoon, is there anything else you want to mention to growers or something that we didn't cover today? The growers know that we've got some nutrition webinars coming up on the next 3 weeks. I'd love to have a little microbiology session maybe with you guys if you're keen. I'm kind of springing this on Edwina literally right now. But I think this space is something that's forever growing and it'd be great to have you guys along for the journey.
Yeah, no, definitely. I mean, like I said, I'm a nerd, so I'm happy to talk about nerdy stuff anytime. So my last thing I'd probably like to mention just before we wrap up is that Australian agriculture and horticulture, and especially the cherry industry, we're at a really cool place where things are being mandated overseas and they're being removed from systems, and we're not quite there yet. So we get the opportunity to start playing with this kind of stuff rather than being told we have to do it. And I really would encourage any grower, cherry or not, to start playing with it. Start thinking about if 10 or 15 years down the track, if something's taken away, am I going to be ready?
Yeah, and that's actually some really good advice. We had another guest on a few weeks ago saying, get in there and trial it, pick a little block, do your own trials, have a look, see if it works for your system, because people can suggest and encourage you to do things, but until you get it in your own orchard, that's where you're going to make the best difference. So, Edwina, thank you for your time today. I know we've had a little bit of technical difficulties with the massive storm here going on in Orange. Hopefully the recording's all good, but I really appreciate your persistence this afternoon and coming on to chat all things microbes.
No worries. Always happy to be disrupted by rain at the moment. So, no, thank you for having me on, and happy to contribute or find you someone that can in the future.
Great. Thanks, Edwina. All right, everyone. See you all in the next episode. Thank you for listening to this episode of the Cherry Picked podcast. If you like what you heard, please subscribe so you don't miss any episodes and refer us to a friend. If you have any feedback or guest suggestions, please get in touch via the contact information in the show notes. Happy growing, and we will catch up in the next episode.